Well, welcome to our webinar here today. We're going to be it's a very, very short webinar, really looking at the asbestos limits and the changes that are going on in the EU at the moment. Some of you may well be very familiar with what's going on in the EU, and some of you might be saying, well, why do we have to worry what's going on in the EU because we're no longer part of the EU? Well, this is really a broad technical discussion about asbestos limits and really where do we see the UK heading in the future, with the EU reducing their occupational exposure limit equivalent to our control limit, and what we should be thinking about where we want to be in the near future and obviously in the future to come. So thank you for joining us today. We've got a couple of presentations, 3 presentations in total, and really the purpose is to discuss and consult what really the practical limitations and difficulties could arise. We're all technicians, we're all working in the field or have done or have experience in the field, and what would reducing the exposure limit have in a practical sense in the UK, and that's really where we want to look at and concentrate today. So for those of you that are interested and want to look more, have a look at the EU website. There are many different versions of the documents around, and sort of more summaries, and the full changes to the directive are in the bottom of that slide there. So it's well worth having a look and seeing the detail. So we've got 3 presentations today. The format will be Gary Burdett will talk first really about outlining the new changes, really the points of interest only. We're not going to go into a huge amount of detail, but we just wanted to raise some of the areas that could be of interest as technicians working in the field, as managers, as duty holders. What are the implications so that we can just start to really understand, and what the timelines are as well, because they've got some very sort of strict timelines for introduction of different OELs. Then we're going to have Jack, who's a practitioner in the field. He's a teacher, he works for GNL. He's got a lot of experience in the laboratory side and the technical side, and he's going to really talk about what from a laboratory point of view, what the challenges could be to meet any changes that we might consider in the UK. And then finally, we're going to hear from James. He's a measurement scientist for the HSE at the Science and Research Centre in Buxton, and he's an expert in electron microscopy. So we're very pleased to have him here today, really just to unpack electron microscopy, which isn't something we use in the UK, but it's very widely used in some countries in the EU. So we want to just look at the pros and cons versus PCM, which we all know and love. We're going to have questions after each speaker. So if you'd like to put your question in the chat, or if you'd like to put your raise your hand, I will do my best to come to you if you want to ask a question in person. But we will try and answer all questions as we go along in the chat. And then at the end, we'll just all come back together and have a general discussion, and then we'll look at next steps. At the end, we will have a very short questionnaire that I'd be very grateful if you could complete. So that's the end of my part. I'm going to hand over to Gary, who's going to share his slides. Now, most of you will know Gary. He's been with us for, well, been part of the fabric of asbestos control in the UK for the last 45 years. And he's a measurement scientist, the same as James, and really sampling and measuring asbestos in air using a wide range of methods has been his real expertise over the last 45 years. He is retired, or I don't think he really is retired, and he's a founder member of FAAM. So we're very pleased to have him here today. So Gary, if you'd like to share your presentation. Thank you.
Hopefully it's up.
It is up.
Okay. I'm saying share from the beginning. Here we go. Okay, so I'm just going to talk about the EU changes and not how we got there. I'll just get rid of that if that's showing. The title is Asbestos Limits, and just for clarity, there's Sorry. Yeah. Okay. My computer froze for a sec. Just for clarity, there's two limits. There's the European occupational exposure limit, which is an 8-hour limit. And what you're more familiar with is the UK 4-hour control limit. Essentially, they're the same. For this discussion. So what the EU amending directive does, which was passed at the end of November last year, is put strict timelines in for the new OELs. And the first one is to, by the end of next year, that we will have a ×10 reduction in the phase contrast microscopy level. So now the OEL will be 0.01 instead of 0.1. And there's also a further requirement that they will reduce it by another factor of 5, an overall factor of 50 to 0.002 fibers per ml by the end of the decade. So this is quite substantial differences. The second part, the second reduction is subject to an assessment of feasibility because they don't know whether it can be done yet. Just to put that in context, this is the table that was produced by the European Chemical Agency on what they think the risks are. And at the current 0.1, which I'm circulating, you can see they suggested there was 125 deaths per 100,000 people if you worked 40 years, 8 hours a day, 5 days a week at that concentration, which nobody does anymore. So the new 1/10 reduction, after their detailed mathematical modelling using a ruler and pencil, reduces by a factor of 10 to 12 deaths per year, and the end of the decade one is 2.5 deaths per 100,000 if you do all that. But if you look at this column here, I've worked out if you didn't know the asbestos were there and you were spending 2 days working with AIB, you could easily get your lifetime exposure at the control limit in less than 2 days. So this raises a big question about, it's more important to know that asbestos is there, because if you can get a lifetime exposure in 2 days, that's pretty dramatic. And the other thing, this is the end of the science, I would just point out the cumulative exposures below about 1 fiber per ml is all extrapolation. There's no hard data to speak of that we're very confident of. A bit, but it's extrapolated risk with a ruler and pencil, essentially. So that's the PCM methods. They've also said they want to change to EM, electron microscopy, either transmission or both transmission electron and scanning electron microscopy, probably going to magnifications of 5,000 to 10,000 to measure a new OEL again by the end of the decade. And they're very keen to do that because you can measure thinner fibers. Why they want to do that, we can have a long discussion on, but anyway, nobody knows exactly what the method is, and SEMs and TEMs see different things. So it will be possibly 2 different indices. So I've called them electron long fibers, or ELFs, because they come in just before Christmas 29. The other important thing to remember is that there are requirements for measuring OELs, Euro norms, their standards, which the EU are supposed to follow. So if you're measuring an OEL, you should be able to measure 1/10 of its value up to 2 times its value. that's another whole ball game. So to actually comply with their own requirements, if we look at it at the UK situation at the moment, the current method for measuring the control limit is 240 litres, 100 fields of view, and at least 20 fibres counted to get an LOQ of 0.04. So if we've got to measure down to 0.001, we have to do 40 times better. So if you want to count 4,000 fields of view, that's fine. So just to finish up, I put down my list of some possible so whats. I can go through them all, but I've already mentioned the last one. It's more important to prevent unknowing or uncontrolled work. We're the UK, not the EU. We don't have to do it. And really, is it not up for the licensed asbestos removal contractors to really clean up their act so we can measure, sample more air? And we also need to think about how can we do what they're doing in Europe? So I'll stop there. And if there's any questions about the changes coming from Europe, essentially points of information, I'm very happy to answer them now, but I don't want to get into long discussions because I want to move on to the next one, which is the lab's view. So any quick questions?
We've got one from Derek. Hi, Derek. How comparable is the OEL to the UK equivalent?
They are comparable, except we would say, because we're measuring ours over 4 hours, it's twice as it's twice as rigid. It's less lax. So we're already doing 2 times better. The UK is doing something better than the EU.
And Derek asked a second question about dust disturbance for clearances. Do the EU do the same? I'm not 100% sure about that in terms of dust disturbance during clearance. Do you know, Gary?
I think it's down to individual countries. The clearance doesn't come under the directive. So I know in France they seem to sample. They do sampling inside an enclosure for something like 40 hours or something, or they used to, for a TEM method, without disturbance, so all I'm saying is that every country does a different thing.
Yeah. And Jonathan, thank you, Gary. Jonathan, would you like to come in? You've got your hand raised. Thank you.
Sorry, I just can't type very quickly, so I thought I'd do it verbally. Gary, I mean, what I'm trying to get my head around a bit is kind of the difference between the control limit and the OEL, because the control limit in the UK isn't really an OEL, is it? Because all it actually does, the control limit in R1, is trigger certain regulations. So can you even treat it in the same way as an OEL? Does the question make sense?
Yeah, it's just a 4 hour instead of an 8 hour. It's still, that they, within the directive, that it's still using the WHO method, for PCM. So that they are essentially upper limits which you're not supposed to exceed. So they're both the same essentially, except a 4 hour and an 8 hour. Okay.
Gary, sorry, Jonathan, just coming in there. Why in the UK did we adopt 4 hours instead of 8 hours for our
because we always did that, and you can, as a nation state, with health regulations, always exceed the minimum requirements. So we were exceeding the minimum requirements of the directive by adopting a 4 hour control limit. Other countries have already moved to some SCM methods, so they've exceeded the minimum requirements.
Okay, well, I've got another couple of questions here, but I think we'll come back to them so that we can move on to our next speaker, Jack. So please bear with us. Some questions are coming in. I'd like to introduce Jack. I did previously, but let's introduce Jack again. Jack is the training manager at G&L Consultancy in the Southwest. He's got 10 years experience on the air testing and surveying side, and has been involved in asbestos removal. So he's going to give us an insight on what he thinks labs would be required, or what the effect would be if we decided to reduce our OEL. Jack, if I can.
Lovely. Thank you very much. Hopefully everyone can hear me. So Jack will be talking about potential effects on the lab. And for some reason my slides have frozen. Okay. So we're talking about the potential changes, how it would affect a UK working lab, and who this could affect. Obviously, our changes may affect other people, and where it's potentially going to be restricting us. So one of the major factors is the time increase. So taking some of these samples, changing our limit of quantifications and things may require, as Gary quite rightly said, increasing potentially the volume of air that we actually do have to sample. Increasing the volume of air that we have to sample, can we run pumps at higher rates? Because currently we're limited at 16 litres, or are we able to expand that, or are we going to have to run them at those lengths of time for longer periods, changing pumps over? Some of our pumps may not actually last long enough, some of the batteries that we have within them as well. Or if we're having to move over to TEM and SEM analysis, we may actually have to take the samples and actually transport these samples to labs where these labs and analyzers and microscopes are. So if you're half an hour away from offices and things like that, where some companies may only have one microscope per office, they have to travel them all that way to potentially even analyze and give us the results of those. So if we are having to do the analysis, that method for clearance indicators, that means the timeframes for enclosures staying up are going to have to be longer as well. Having those enclosures up for longer means we've had recent changes with the analytical stuff anyway, recent guidance, but increasing timeframes on that, we're going to be increasing it even more. The one-day jobs are becoming very, very tight in time. Having to drive the samples away, it may actually be completely exhausting the time we have for one-day jobs. Imagine almost the emergency jobs as well. We're having to go do quick analysis to try and work out have we exceeded limits and things, but we've actually got to drive away. So can we clean up and make areas safe for people to reoccupy with the length of time that's going to have to analyze them? By increasing the time frame, we're going to be looking at potentially increasing the amount of staff that we have. And a lot of analytical companies we talk to all struggle from the same side. We are struggling for staff within the industry. It takes a lot of time to find members of staff, train them up to the levels of analysis and things that we need to. So we're potentially increasing time spent on site, increasing travelling times and all those types of things, but potentially having the same amount of work that is out there, which all involves increasing the cost. So enclosures staying up for longer, so removal times may be longer. The analytical time spent, potentially cost of fuel, driving things back. Increasing in new equipment as well. So if we do have to invest in SEM and TM microscopes, these range, starting from a couple of £100,000. Some of these microscopes is quite an investment for companies to have. Are we having to buy new equipment and things like that, like pumps, and investing different costs? The cost of, unfortunately, maybe even those one-day jobs, you think of tenants being within, can't go back into buildings, having to actually be put in hotels and things overnight as well. So doing this analysis, dropping these limits that we're trying to look at, we potentially may actually have to look into looking at the removal methods that we're using. So changing removal methods to releasing less fibres in the air, if we can do that, potentially making it a lot easier for us to analyse. Because at the moment, when we're using PCM, there's a lot of ultra-fine fibres that we don't actually analyse under PCM microscopy. So if we're moving over to SEM and TM and using the same removal methods, we may actually start picking up more fibres doing exactly the same job, which is potentially making it worse because we're actually trying to lower our results, but we're actually finding more fibres. So do we need aid of removal methods? Are we having to increase ventilation, wetting techniques, anything along those lines to try and find those ultra-fine fibres? Are we going to have aids with visual inspections if we do have to change anything from the clearance side? So visually checking the enclosures clean before we do the analysis, using torches, we are potentially missing those ultrafine fibres in dust and things. Then we're doing those dust raising activities that was brought up a second ago, kicking those into the air. We're now potentially going to be analysing more fibres actually in the air than we were previously. And then are we going to be able to differentiate between interfering fibres? With PCM microscopy, we're not allowed to differentiate between fibres. You ask people's opinions, though. Some people believe that they can tell the difference by the naked eye, but again, we can't actually prove the differences between them. So fiberglass and things like that, we can potentially visually see the differences, but timbers and other things look similar to amosite under the microscope. So could we potentially train staff to tell the differences between them? Maybe a thing to potentially think of. And then some of the results that we need from our analytical side, we almost want an instant result. You're like leak tests, checking outside the enclosures. We want to be checking that these limits potentially are not being exceeded as soon as possible. Are we going to be able to change any methods potentially for that? For personal monitoring, of course, checking exposure levels, checking potentially capability of RPE for the exposure limits and things as well. We want a quick result to see if we're going over protection factors. By increasing all of that, we're going to have to change potentially the type of respirators that we use as well. So changing our APs, APFs. Are we going to have masks anymore, or are we always going to have to be in full faces and increasing our respirator protection? So just a few things there that potentially, from a lab's perspective, what we could potentially be coming up against. So it's just starting that decisions. What do we think of as an industry? If this came in, what methods potentially could we do? Do we need to start innovation, increasing standards, and looking at different technologies to start us off already? Thank you very much.
Thank you, Jack. I think, all of us, as we're thinking about this, what the implications. PCM seems to be completely out of favour in the EU, and as Gary explained, the timeline for removing that as the main method, which obviously we've adopted in the UK and we've been using that for 40 years plus in the UK. What are the implications of going over to electron microscopy, which are favoured in many countries in the EU and is up and running in many countries in the EU? And I think possibly they're the driving force behind this. Has anyone got, I've not seen any more questions coming through for Jack's, but certainly Jack, sorry, I've got some hands up here. I know Kat had her hand up. Did you still want to ask a question, Kat?
Hi, Sarah.
Hello.
It was
Hi,
just, I suppose it's, hello. Hi, everyone. I just suppose it was a little bit related to Gary more than Jack necessarily. I just wondered if you thought that obviously the TEM and the SEM requirement is so that we can measure down further and support this move. That's what they're going for in Europe, because it aligns with dropping down the concentrations that we're measuring it, isn't it? Does that negate the need to have better pumps and pull through more volume? Do you know what I mean? Because we're looking at it links to what Jack's saying. We'd have to change, the capacity of the pumps and things like that. Does that negate that if you're using TEM? Because clearly you can potentially look at more volume, because you can look at more graticules. Could we use AI to look at more volume on what we're collecting already? And then, as Colette said in the chat, I think that's a really interesting point. If her understanding is that the levels don't relate to clearance air testing at the moment, it will still have an impact surely on the clearance indicator as well, won't it? Because the clearance indicator is effectively going to be the same as the control limit, which is blowing my mind as well. So they're just things to think about, really. I don't want an answer.
I'm not sure you'll get one, Kat. I'm not sure you'll get one from us, but yeah, it is definitely food for thought, isn't it? We've been doing the same method for 40 years. Yeah. We've not changed. I've just been asked a question on the chat about innovation. Where are we headed? We haven't got a lot of innovation. We've got to support innovation. We've had the Alert Pro, for instance. We really need more innovation. We are certainly at the conference this year in October. Good plug for the conference. We're going to be having a little bit of insight into where innovation is at the moment. We've already last year talked about the Marvin AI microscope that's available and being used widely in the US. We've not brought that into the UK. Is there an opportunity to do that? And maybe FAAM could, with others, collaborate on some research to see if that's worth exploring. But then they're not going to have a market in the EU because everyone's going to move away from PCM. So there are so many questions, and I think everyone's sort of chasing their tails a little bit in the EU to understand where they need to go. So thank you for that, Kat. There are some questions coming in. I'm trying my best to field them as I go through, but it's all heating up now. So thank you to everyone that's replying to some of the questions as we go along. But we certainly can't, sort of answer them all as we go along. But anyway, we'll do our very best. So thank you, Jack. I think there are some challenges. I think RPE will be a real challenge because if you reduce the control limit, everything is based on a sign protection factor. And as Jonathan talked about earlier, when you're talking about OEL, that's the upper limit. That's not, we've got to reduce it as low as reasonably practicable, or is it technically practicable at the moment? So there are challenges in that as well. It's not just about the control limit. And of course, most of us that measure in the field know already that we're not counting that many fibres anymore. 40 years ago, we would have known what an amphibole fibre looked like because we were dry stripping. Now our techniques have got a lot better. The industry has improved. So we're already seeing that we've reduced potentially our control limit, our clearance indicator, because of the better methods. Who knows? We just don't know because we don't have that research at the moment. Anyway, I'll stop talking. I'd like to introduce you to James. James is going to present and now talk about electron microscopy as he is our expert here today. Thank you, James, for joining us from the HSE at lovely Buxton. And I'll leave you to introduce your slides. Thank you.
Hi, everybody. Right, let's get these slides going. There we go. Yeah, so I'm James Staff from Health and Safety Executive Science and Research Centre in Buxton. I'm just going to give you a little overview of different possible techniques for fibre counting. So what are our options? So phase contrast microscopy, which is light microscopy. You'll all be very familiar with that, I'm sure. I'll also talk about scanning electron microscopy, or SEM, and transmission electron microscopy, or TEM. So how do they work? Phase contrast microscopy and transmission electron microscopy, TEM, they both work with a thin sample where a beam passes through the thin sample and produces an image. The phase contrast microscopy works using a beam of visible light. Transmission electron microscopy works using an electron beam. Scanning electron microscopy, or SEM, also uses an electron beam, but that scans across the surface of the sample. A detector then collects the resulting electrons and produces an image. So the techniques all have their own advantages and disadvantages, and I'm going to try and run you through those now. So which fibres can you see? Phase contrast microscopy, because it uses light. There's inherent limitations due to the wavelength of visible light, which mean that only fibres greater than around 0.2 microns in width can be seen. So the very thinnest asbestos fibres can't be seen using PCM. So it gives you an index of exposure. It doesn't give you the entire asbestos fibre population, but it gives you an index of exposure. SEM and TEM are capable of seeing all asbestos fibres. However, SEM, in order to get a good image to see the very thin fibres, it takes a certain amount of time to scan. So you're not really seeing the image in real time like you would be on PCM and TEM. Can you differentiate fibres? So this has been touched on already, but by PCM, you might get some clues from the morphology, but ultimately, no, there's no surefire way of telling different fibre types apart. SEM and TEM, you have some additional tools to work with. On both of those, you've got something called energy dispersive X-ray spectroscopy, or EDX, which allows you to tell the elemental composition of the fibres, which is really useful for telling asbestos from non-asbestos or different asbestos types from each other. On the TEM, you've also got something called selected area electron diffraction, which gives you extra information on the crystal structure. So practicalities, PCM, as you know, it's portable, it's robust, the analysis can happen on the site, which means that the results can be provided quickly. The sample prep is also pretty quick and straightforward. SEM and TEM are not really portable. There are some benchtop SEM instruments, but they still have they're still very big and have high power requirements. So you couldn't really run one out of the back of a van, for instance. So that means the samples have to be transported to a lab, as Jack talked about already, which introduces delays. They're both more complex bits of kit, therefore the more likelihood of breakdowns, which is something else to factor in. SEMs, the sample prep is pretty quick and straightforward. TEMs, there's a little more sample prep involved. Cost of the instruments, PCMs are fairly cheap instruments. Maintenance and parts are also relatively cheap, and there's no significant energy requirement. SEMs and TEMs, the instrument itself is a lot more expensive, and there are other costs such as service contracts, replacement parts, and energy consumption to factor in. In terms of interpreting the results you get, PCM's been used already for decades to monitor airborne asbestos, and many sort of existing risk considerations are based on PCM data. There's a big sort of repository of historical data to go back and compare to. SEM and TEM, they're still very well established methods, but they are newer and there's less available historical data. Also, it's not entirely straightforward to compare new SEM and TEM data to historic PCM data. So sensitivity, if we're wanting to measure to lower concentrations, we need extra sensitivity. For all of these methods, the sensitivity depends on these factors. So the air volume sampled, the field to deposit area, the area of each field of view, and the number of fields counted. Between these techniques, the area of each field of view varies perhaps less than you'd think. Although there's a big difference in magnification between PCM and the electron microscopy techniques, PCM uses a small graticule, whereas the electron microscopy uses a big screen. So those do, to an extent, cancel each other out. So it's down to the number of fields counted, really, and how long do you want to spend counting, which is a bigger question. Automation could potentially allow a lot of fields to be counted very quickly, and that could be the case for any or all of these techniques. But then we'll see what the future holds. So overall, this is just a summary of all the points I've made. There, as you can see, there are pros and cons for all of the techniques. There's no standout winner, if you like. There are pros and cons for all of them. And this is just a little summary. SEM and TEM give you much improved analytical capability. They can do more in telling fibers apart, for example. But PCM is very practical. It's portable and it's cost effective. So yeah, there are decisions to be made on what's best for a particular use. And thank you very much for listening.
Thank you, James, for giving that insight into electron microscopy. James, do we know how many commercial SEMs? I don't think we've got any TEMs, have we? Or have we got any TEM commercially in the UK?
I mean, we at HC Science and Research Centre will do commercial TEM work. It's not cheap, but yeah, we do some work. SEMs probably somewhere around 10, I think, in the UK operating commercially. But yeah, far more in sort of European countries, sort of Germany, Netherlands. SEM is the main technique. Yeah, TEM's operating commercially for asbestos analysis. There's us and there's Brunel University in the UK.
And definitely not portable. I thought there were some in the Netherlands that they had sort of made portable, whether they're TEMs or SEMs, I'm not sure. I remember Jan Tempelman talking about it a few years ago.
TEMs are not really portable to any great degree. SEMs are they've become a lot more portable in recent years. There are sort of benchtop ones. However, benchtop instruments tend to be sort of at the lower end of the specification, because they're sort of trying to get everything small and portable. I think they're not there yet to a point where you could straightforwardly take them onto a site and use them. It's not to say that that won't ever happen, but yeah, they're not there yet, in my opinion.
Okay, thank you. Gary, you've got your hand up. What would you like to contribute?
Yeah, I just wanted to a couple of questions in the boxes, just to explain that the new amending directive is wanting to count all thin fibers. That goes down to about 0.01 microns. Now, that's very, very difficult to do with a conventional SEM. So all these benchtop or mobile SEMs, what they're doing is using, roughly 2000 mag to count optically equivalent fibers. They're not doing what the EU is asking to be done by the end of this decade, is to count all thin fibers. And I don't think you can count the thinnest fibers, especially of chrysotile, without a FEG SEM, which is a very expensive and large piece of equipment that won't fit in a van. So all these SEMs that are used at the moment are counting fibers down to 0.2 microns. It's the same as an optical microscope. You're just doing some differentiation of fiber type. To get down to count all fibers, longer than 5 microns, the very thin fibers, you do need higher magnifications, and it's not simple and it's not cheap. Now, if the EU decides that's not what they want to do, fine. But I wouldn't buy, if you're going to buy an instrument, you need a FEG SEM or a TEM, in my view, from what they're saying in the directive at the moment. If you go and buy an ordinary SEM, it won't see these thin fibers, or you're, in practice, at normal scan speeds, you'll be in problem.
You're on mute, Sarah.
Oops, hangover from COVID. You're on mute. Steve Foster, would you like to ask your question? As long as it's short. Steve, do you want to unmute? Hello, Steve. Okay, we'll go to Laurie and then come back to Steve. Laurie, what would you like to ask?
I'm unmuted now, if that helps.
Are you unmuted? Okay, then. Hi, Steve.
Hi, Sarah. Just an observation. No, I'm not camera ready. The recent publication by BSI of the technical specification for identification and quantification of asbestos in construction products, and for that recycled aggregate, has PCM, but there's a very strong pointer towards SCM as well. And I just wonder if the UK labs that working their way through that in the future, near or medium term, may choose to acquire SCM, and in which case it might open up the SCM landscape in the UK. I don't know, but it might be a very, very wise thing to do in view of the fact that it's now best practice for identification and quantification in recycled aggregate.
Steve, would you, on the chat, would you put have you got a link to that BSI document? Will you send it through? Some
British
people might
Standards
not be
Institute
aware.
BSI website.
Yeah, but it's the title, because it's not that easy to find. If you wouldn't mind putting it up, that'd be really useful. Or send it to me and we'll send it on later on. But it is a very interesting point. The landscape is changing in terms of testing of materials other than just what we love and know from buildings in soil and recycled aggregate. So yes, it is something labs need to consider. I presume you're referring to the stage 3 analysis, if people are familiar with asbestos in soils, which was in the old standing committee method, which we're still waiting for that alternative, and maybe the British Standard will provide that. But that's a different discussion. But I think you're absolutely right, Steve. It is something we might need to consider and move to. We've lost Laurie, but we've got Nick Garland as our next person that wants to ask a question. Nick, would you like to ask your question, please?
Yeah, there's a danger, I think, that we're focusing on the wrong problem. We seem to be talking a lot about how we adopt, or can we adopt, or should we adopt SEM, TEM to do this, whereas actually the problem we're trying to address is, can we test down to these new, more difficult, more challenging OELs and ultimately the clearance indicator? And if we focus on that, then we're more likely to open our eyes to AI use of, PCM. Gary has mentioned in the past potentially actually measuring total dust as an indicator of how clean it is inside an enclosure. And I think we need to stay open a bit and really keep focused on the fact that we're looking at measuring to low levels, and the answer is not necessarily SEM, TM for the problems that have been already raised. And rather than trying to solve the problem of how we adopt SEM and TM, we should be still looking at what the original problem is. How do we test down to those new levels?
Gary, would you like to come in on that one?
Well, just very briefly, I think I mentioned at the beginning that the problem is for larks, unless there's really good control, it's very difficult to measure what the EU are asking. If there's a load of dust, you can't sample very much air. So, and I have this simple idea that you're very clever if you can remove the asbestos from the general dust when you're removing asbestos. So monitor the dust, and then you know how well you're doing. So yes, it's all about primary control at source. And that's something that FAAM is working on through its research committee. And if you come to the conference, you'll find out more. But yeah, the simple answer is, we're second along. It's up to the licensed asbestos removal contractors to show that they can get that level. And, so that's my point of view.
Thank you, Gary. And thanks, Nick, for pointing that out. I think, at this point, it really is only a discussion of what the challenges could be. And, where do we want to go? Do we want to have more discussions on this? Do we need to, as a body of FAAM and our members, talk about what those challenges are? And, do we want to head that way in the UK? Do we want to talk to our regulator and, look at our position and what is happening in the UK at the moment? There are lots and lots of questions coming through on the chat. I'm trying to get through to some of them, but can't get through. Thankfully, some people are answering them for us, which is very, very kind of them. I haven't got any more people that are asking burning questions in person. If anyone would like to now, before we draw to a close, because I'm very aware people want to get on with their day. If we haven't, I'll just say thank you very much. I'm struggling to get on my chat, but I see Colette's just put up a post with Gary or James. Could you, or Jack, could you see what that is? Because I can't actually see the question for some reason on my chat. Oh, I can now. Thank you. So is it possible to, this is from Colette, is it possible to measure down to lower levels? I did a presentation at FAAM, blah, 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 covered. Sorry, I'm finding it difficult to read it. It wasn't blah, blah, blah. you know, where we're talking about, well, yes, I mean, with PCM, we can go down to lower limits. We've just got to count more fields and not have so much background dust. So yes, we could get down to lower levels. We can do it outdoors, but maybe buildings will give us different challenges. But on that note, thank you, Colette, and I'm sorry I didn't answer that in full, but there are many questions. We will take these questions, we will have a look at them, and then we'll send them out later on when we've got them compiled, and then we can decide where we want to go next, really, in terms of the last. Sorry, I'm just getting my presentation up.
Well, we've still got 10 minutes, Sarah, according to my clock.
Yeah, I mean, if someone would like to share, unfortunately, my chat for some reason is not very well at sharing. So we've got some other questions. I've got here, okay, I've got one here from Maria. Thank you, Maria. Would SEM be the best option for clearance testing? James?
That's for me.
Yeah.
I mean, it's clearance testing. I don't want to say for definite one way or another, really, but I mean, clearance testing is on site. If you have to send a sample away to an SEM and get that back, that introduces a big delay. I can certainly see big advantages to doing that by PCM on site and getting the answer sooner. However, SEM does offer those analytical advantages. It offers the fiber differentiation, which may also be useful, you know, hypothetically, in a situation where there were some sort of non-asbestos fiber generating materials there too. You could have a situation where there were non-asbestos fibers still around that were being picked up by a PCM and sort of preventing it passing the clearance, but SEM would be able to tell those apart. So it's very situation dependent. Yeah.
Yeah. So in other words, it's not an easy question to answer.
No.
Both
like many of these aren't.
Sorry, both still rely as well, SEM and PCM, on someone actually viewing the graticule area and counting. So
sure.
That's always the massive variability in both systems as well.
Yeah, absolutely.
Can I add a point of information? It's already in HSE guidance that if you're having trouble with clearance, you can go to a fibre differentiation method like SEM or TEM, because sometimes you won't be able to get clearance if there's lots of other fibres there. So it's not, you know, it's already possible to do that if you need to. But the real issue, again, is that if there's lots of fibres, you know, unless they're coming from outside, you haven't cleaned very well, whatever they are of. You know, it just depends on the situation. You know, if you've got lots of man-made mineral fibres there or something and you haven't removed them, but in reality, you know, if it's clean, it should be clean.
We do it in personal monitoring though, when we're doing sandblasting and things like that, for cleaning walls off. There's no way of doing PCM microscopy for personal monitoring of those. We do have to send them away for SEM analysis because the amount of dust and thing that settles on them, even like plasma ashing and things, isn't it, James? But they do before we do the analysis, I believe.
Yes, just sorry, I'm just catching up some of the questions here. One of them is talking about AI, PCM using AI. I know, you know, sort of it's widely used in, well, I say widely, it is used in the US, and some on the chat might be able to allude on that, but it is a possibility that we could bring it into the UK. But you know, again, my point about we've used the same method for so long, and we're slightly, and this is very much a personal opinion, because we are so tightly regulated and have tight guidance, we've been very reluctant in the UK to look at innovation to move things forward, because why would we? Because it's a commercial field. Why would we look for things that are outside our Lab 30 or whatever guidance we've got. So it's always been a difficult one, but I think we have an opportunity as an industry now to look for commercial opportunities, which could mean innovation. And I think that's really important. And AI could feed into that. Analysts have a tough enough time on site taking fibre counting away from them, and maybe improving quality control on that could actually be of a benefit in the UK. So I think AI is knocking on the door, literally. Just looking at some of the other questions on here. I've got from Neil Grabham, has the HSE stated if they would consider following the EU approach? Well, we do not know that, I'm afraid. When the HSE have considered it, which I'm sure they are, then I'm sure we'll get to know more. But at this point in time, I don't know any detail on that, so I'm afraid I can't answer that. Just thinking, anyone else? I think Kerry, did you have your hand up? No, I've got Dave Birkin, or David Birkin. Would you like to come in, David?
Yeah, thank you. Yeah, one of the things that was raised earlier was pump technology and how long they run for. For the last 4 years, we've been doing high volume sampling of up to 8,500 litres, and we got pumps that run at 16 litres for 12 hours. No problem. So that technology is out there. I just wanted to say that as a bit of a reassurance to people.
And would that be for the built environment, or is that for external environment, David?
Both. We done 3,500 litre samples inside, getting down to 0.0005, and 8,000 litre samples outside, getting down to 0.0002. Obviously, you've got to count 500 or 600 fields to get that level of accuracy, but yeah, we've been doing it for 4 years, done about 15,000 tests. So yeah, it's very routine.
Brilliant. Innovation. I like it. Thank you, David.
To know the brand of that, to be honest.
Pardon?
Interested to know the brand of the pumps and things like that. I'm involved with that.
Yeah, they're the Airbox ones, XLs.
Airbox XLs. Thank you.
Perhaps, David, after you could get in touch separately, David, and just share that information with you, because I think other FAAM members would be really interested in the work you've been doing. So, and others may well have similar instances they might want to share. So, yes, if you don't mind, I'd be very grateful. Thank you for that, David.
Okay.
Joanna. Hi, Joanna.
Hey, Sarah, you okay? Just I don't know if it's a question, more of a comment, I suppose, is that unless there is sort of direction from the government or from the regulator, it's a really big gamble to expect asbestos consultancies to take on with this, I suppose, because, you know, potentially having to seek new suppliers or train staff, buy lots of expensive equipment, and all within potentially 5 years, which isn't, on the grand scheme of those things we just said there, a long time to try and take that. For myself, I'm a client, and the risk for me is that am I going to end up in a market where I'm having to compete with people for the services that I need, because it's a lot to ask these companies to take the gamble on whether this will or won't be sort of brought in, I suppose.
Yeah, I can understand that from a client's point of view. I think at the moment we're just really exploring what the arena would look like if we adopted similar stringent measures in the UK that they are in the EU. And of course, you know, it wasn't that long ago we were part of the EU. So it's just an interesting debate to talk about where do we want to be in the future in the UK. And of course, we've always been leaders in this field, and now it feels maybe we're not leading anymore, but others might have a different opinion on that. But thank you, Joanna. It's really important to hear from clients' point of view. We've got a few more minutes left. I'm just again looking through the chat. Again, Kerry Morgan, thank you, Kerry, from Magnox, is just asking about high flows. You have been using high flows for a good while too, haven't you? Have you found much above background levels? Maybe David, you could come back in on that. we're obviously keen to know what background levels are with asbestos generally in the environment. Kerry, you put your hand up. Do you want to come in on that and explain your question?
So we've got 2 consultancies working for us on our decommissioning nuclear power stations for NRS, previously Magnox. So we've been looking at driving down some of our, we've called it ambient background air testing, down to 305. So they're running pumps for a long time. We've been getting about 7,000 litres, counting about 300 grad-school areas. We cut all our filter papers in half as well to retain a half for SEM in case there's an issue. And yeah, we had a lot of skeptics at the start that the pumps were all going to get occluded and fail, but we have managed quite a lot with a trial period of doing some that have been countable and give some good results, and generally got down to that limit.
And did you say down to 205 or was it 305?
3.
3. Thank you. Well, it is possible then, isn't it? That's 2 examples that we've had as possible of ambient monitoring without having, occlusion with dust. So that's interesting. And, if we don't share this information, none of us will be any of the wiser. So it's really important that we do share it. So thank you. Thank you for that, Kerry. It's good to know that the technology is working, even without SCM needed. There's a question here about asbestos in schools. This is from Neil Williamson. Hello, Neil. Expected difficult questions raised if levels are measured above the new limits during air testing in schools. I guess, there are many questions to ask in very sensitive locations such as schools and hospitals, how we are continuing to monitor them. And don't forget, the HSE have just run a big programme looking at asbestos in situations such as schools and public buildings. So again, that's going to be disseminated at the FAAM conference. So please come along to that, or certainly find out more about it from the BOHS FAAM website, because that's important, because again, they may well have been using, and I don't know because I haven't seen the report yet, very much lower limits than we're achieving in our day-to-day work. So again, that would be an interesting talk to listen to. Okay then, well, we're nearly there. We've got 2 minutes. I just want to go round each speaker and just sort of have a sort of roundup of their thoughts of today, and any future webinars we might think about carrying out. So can we start with Gary, just to finish off, Gary, in the last couple of minutes?
Yeah, it's a complex subject. We need more webinars, there's so much to talk about. And we are putting out a little survey after this just to get a bit of feedback, which so we really need you to come along with us, FAAM, and go along this journey.
Thank you, Gary. Appreciate your time today. Jack, have you got anything else you'd like to just relay while we're closing down?
Yeah, so sort of really what you've added on there. So yeah, the people out there already doing these analyses, so we need to share that information throughout the industry and ensuring that everyone's able to have an understanding of how we can get to these lower numbers, definitely.
Thank you. Thanks, Jack, and thanks for your input today. James, if you'd like to just sort of give a few pointers.
Yeah, I mean, I think sort of comparing the different techniques, I would sort of go back to that last slide with the arrows on it that I had. The electron microscopy techniques can offer you some really good sort of analytical advantages over PCM. However, they come with costs in terms of practicality and being able to have that analytical capability there on site like you can with PCM.
Lovely. Thank you, James. And thank you to all our speakers for joining us today. I think I've got one last slide here. Yep. Just say thank you to our speakers today, and obviously thank you to all of you for attending. We had a good attendance of nearly 150 people. So it's really reassuring that people want to know more about this and where we should go. And as you can see on the slide here, we've got QR code there for the questionnaire. It's a very short questionnaire, which Kat put together, which is brilliant. Thank you, Kat. And just really to sort of give us a bit of feedback on where we want to go and whether we want more webinars or what you're looking for, in other words, that, or how FAAM can help. And we will follow up with an email as well. So if you don't capture that QR code now, we'll send it out in a questionnaire in a separate link. So again, another plug for the Asbestos Conference. Some of you are familiar faces and will be at the conference. It's in the 8th and 9th of October. It's in Sheffield this year. So please come and join us for some time to share ideas and obviously listen to some great speakers. So thank you very much for joining us all today, and we look forward to seeing you at the next one. And as I say, any questions we didn't get to answer today, we will put in a format and we will share those with you later on in the next few days. Lovely. Thank you all for now, and have a good rest of the day. Take care. Thank you.